Good afternoon. My name is Minailov Dmitry. I study at Novosibirsk Chemical Engineering College named after Dmitry Ivanovich Mendeleev. As a schoolboy, I was involved in different sorts of projects. Thanks to my college advisors in 2018, I won the main prize in the regional contest held by the Education Research Center Altair. In 2019, I became the winner in the competition Big Challenges held by the Education Center Sirius. The results of the research were published in the article. The research deals with lithium-ion battery components. Lithium-ion battery perfectly stores and transfers energy. Therefore, it is used not only in portable devices, such as laptops, tablets, smartphones, but in electric cars as well. The future growth of this type of transport is expected. I am engaged in this direction as it is relevant. We are inside Novosibirsk Chemical Engineering College. It offers ample opportunity for students to do science. In this laboratory, for example, we have high-precision analytical equipment for powder material analysis. This equipment allows to select synthesis modes and see how the changes affect the final characteristics of the powder material. Select laboratory technology for the synthesis of cathode material in a batch of 100 grams. This is the first stage of large-scale production. In the first part of my presentation, I will tell you how a lithium-ion battery works, what are the promising applications. I will guide you through this laboratory and show the entire process, from the very first stage of synthesis to the analysis of powder material. The main components of the lithium-ion battery are anode, cathode, and electrolyte. Scientists are improving the properties of these components, so batteries last longer, charge faster, and have more capacity. Now we will show you how a lithium-ion battery works. Guys are wearing T-shirts of different colors, which symbolize certain atoms of substances in lithium-ion battery. Dmitry and Igor symbolize graphite. Katya symbolizes the atom of cobalt. Nikita symbolizes the electron. Sasha and Nikita symbolize atoms of oxygen. Also, Katya symbolizes the atom of manganese. Vera symbolizes the nickel atom. Nikita, Vera and Katya symbolize lithium atoms. Also, Dima and Igor symbolize dopants. Now we need electrolyte, cathode material and anode material to build the battery. The background will perform as the external battery circuit. The guys symbolize the graphite crystal lattice, into which the lithium ion will later be embedded. Imagine that there is an electrolyte around Vera, and she is a lithium ion in it. This is the crystal lattice of the cathode material. The electron is held by cobalt, but the electron can easily detach from the cobalt. But now it is holding onto it, and the electron, as you can see, is embedded in the crystal structure of the cathode material and forms a bond with oxygen. As for the process of charging, first cobalt is oxidized, so an electron is detached from it and passes to graphite through an external circuit. Then the lithium atom turns into an ion, leaves the crystal lattice of the cathode material and enters the electrolyte. But look! There is another lithium ion in the electrolyte, which makes the room. The released ion of lithium follows the electron. In turn, the electron is already embedded in the crystal structure of the graphite. And finally, the lithium ion is integrated into the same crystal lattice. Now the guys will show the process of discharging the battery. Notice that the process will start by moving the lithium ion. Only after that, to be followed by an electron, the lithium ion starts moving first, which entails an electron, which in turn goes through an external circuit. The lithium ion is replaced and enters the crystal structure of the cathode material, and then forms bonds with oxygen. Now it is a lithium atom. Now we know how the lithium-ion battery works, and we can discuss how it can be applied. The challenge is to improve the technical specifications of the lithium-ion battery. Scientists have developed a layered material with lithium ions accumulated between the layers to increase the power of battery. To increase the voltage of the battery, a large potential difference is created in the following way. For example, the anode material will be graphite and the cathode material will be nickel, manganese and cobalt. For the battery to work longer, it is necessary to reinforce the bonds of the cathode material, because little destruction occurs during the charge-discharge cycle. But it is important not to destroy the cathode material. So scientists introduce special additives. They are called dopants, which strengthen the bonds and prevent the material from being destroyed. This is a lithium atom surrounded by three transition metals: nickel, manganese and cobalt. Oxygen is attached to these metals. Warning! This is the crystalline lattice of the cathode material. During the charging process, the lithium ion leaves the lattice. These bonds are unstable and can break. That's why special dopants are introduced, which reinforce the transition metal bonds, and as we can see, the crystal lattice is reliably bonded and not torn now. That's all about theory, and now we move on to practice. I will show you how I synthesized the material and analyzed it. In this lab, we analyze the cathode material, which we received. For a lithium-ion battery, it is necessary that the cathode material must be placed tightly on a special aluminum foil. We need to measure the density of the cathode material, which we have synthesized. We find the density through the volume to mass ratio. Mass is measured by analytical scales. To determine the volume, we need some other facilities. The first is auto-tap. Here it is. It is based on the method of shaking, and there are special marks on the cylinder, by which we determine the volume of powder. There is another way, more accurate, of determining volume. This is the multipycnometer. It uses gas. We put the material inside, turn on the gas, and according to Archimedes and Mendeleev-Klopeyron's law, we find the volume of the powder. It is also important for us to know the surface area. To do this, we need sorby. It uses helium and nitrogen. We also determine the particle size. We have two types of equipment for that. This is granulometer, which is based on the principle of Brownian motion of particles. The second device is a photosedimentometer, which is based on the rate of particle falling under gravity. We have to get the material to analyze it. Now we are going where we can get it. Here we are. So, here you can see salts of three chlorides, notably salt of nickel, manganese and cobalt. We dissolve them, and we get a brown-colored solution like this. Then we dissolve the lithium hydroxide separately, and then add it to this solution. In practice it looks like this, already at the end of the ion exchange reaction. between these substances. We have a precipitate of complex insoluble hydroxide, which is evenly mixed. Lithium chloride remains in the solution. We don't need lithium chloride, and with the help of the centrifuge, we get rid of this solution. We have a box, where we put the mixture. Then it centrifuges. The sediment sticks to the bottom. The solution remains on top. We flip it over with a simple movement of the hand, and the solution flows down, and all that's left is the precipitate. We take it out and dry. Let's go to the second zone. Here we also do the synthesis, but in a different way. We grind the centrifuged and dried powder in a centrifugal planetary mill. Here it is. Beforehand, we mix the obtained powder with lithium hydroxide and put it in a box. In the same box, we put balls, which grind the material at a high speed. We take out the powder crushed, pour it into crucibles, and put it in the furnace. We added lithium hydroxide. The idea is that the lithium starts moving fast under the high temperature in the furnace and gets into the crystalline structure of nickel, manganese and cobalt oxide. When it is inside that crystalline structure, it is already cathode material. Thanks to modern equipment, we were able to measure all the physical characteristics of the resulting cathode material in this laboratory. And that was the idea of my project. Goodbye, everyone!